everyone, it's Coach Fred here, and today I'm going to be going over solving radical equations that involve one radical or two radicals. But let's just remember that when we solve equations, we're finding a value that makes the equation true. That's what we do when we solve equations. Equations normally have one variable. Functions have two variables. And so when I solve an equation like x squared equals 25, in order to solve it, I'm trying to solve for x. So I have to undo the square. To undo a square, we take its inverse operation. So we take the square root of both sides. And we know that x then would be plus or minus 5. All right, now if I want to work backwards, okay, and I want to solve a radical equation, I'm going to, instead of taking the square root of both sides, I'm going to square both sides. I'm going to use the square root's inverse, which is a square. All right, but there are some steps that we need to know to solve. Okay, so first we need to isolate the radical if it is not already. Okay, move terms first and then divide by any coefficient of the radical. Square both sides of the equation. Solve the remaining equation using approaches you already know. The most important thing is that you check all possible solutions in the original equation to be certain they actually give you a true statement. We may get false answers, and they are what we call extraneous solutions. Extraneous solutions. Okay, so here's an example. The square root of x plus 1 equals 7. All right, well, I'm going to undo the square because everything is isolated. I'm going to square both sides, giving me x plus 1 equals 49. I'm going to subtract 1 from both sides. I'm going to get x equals 48. All right, I'm going to check my answer. The square root of 48 plus 1 does, in fact, equal 7, so I'm good. All right, I'm going to isolate now. Looking at number 2, I have a 5 being multiplied to that radical, so I need to divide both sides by 5. So I get the square root of x plus 7, fix that, equals 5, and I'm going to square both sides. That's going to give me x plus 7 equals 25. Subtract 7, and you can see I get x equals 18. So these are just some basics, right? I still am going to check my answer. So 5 times the square root of 25, does that equal 25? Square root of 25 is 5, 5 times 5 is 25, so yes, it checks, okay? All right, let's look at number 4. Number 4, oh, actually, let me not skip 3. So this one, I'm not being multiplied to the square root of x plus 8, but I have a number on the outside. Be really careful noticing it's not under the radical. So I'm going to subtract the 4 to both sides. All right, now, what you've noticed here is that when you've done that, you now have the square root of x plus 8 equals x minus 4, not just a number. Got to be really careful. We square both sides. And now remember, that is the square of a binomial. So we know that when I multiply it out, we're going to get a perfect square trinomial. Right? So that's going to give me x squared minus 8x plus 16. Square of a binomial, perfect square trinomial. All right, so now I've got a quadratic equation. Quadratic, I'm going to need to get it set equal to 0 and see if I can factor it. How do I know it's quadratic? Yes, because the highest exponent's a 2. All right, so let's see what we got here. I'm going to subtract x and I'm going to subtract 8. That's going to give me x squared minus 9x plus 8 equals 0. All right, let's see what happens. I'm going to solve by factoring. That is factorable. I can factor it into x minus 8, x minus 1. I can apply the zero product property to get x equals 8 and x equals 1. But again, I got to check this. Now, you could check here or here. That's kind of up to you. I'm going to go back to the beginning. So the square root of 8 plus 4, does that equal 8? All right, this 8 plus 8 is 16. Square root of 16 plus 4 is equal to 8, so 8 works. All right, let's see about 1. The square root of 1 plus 8 plus 4, does that equal 1? Well, the square root of 8 plus 1 is square root of 9, which is 3. 3 plus 4 does not equal 1. That's 7. So 1 is an extraneous solution and it does not work. Yeah, it happens a lot on these equations because you're changing the equation to solve it. So you have to consider that by changing it, you could be introducing a number or throwing out a number. Got to be really careful. All right, and number 4, we've got to just make sure we can use all operations. Again, the goal is to isolate the root. So I'm going to first subtract 10. Okay, that's going to give me negative 2 root 3x minus 1 equals negative 24. I'm going to divide by both sides by negative 2. And that's going to give me the square root of 3x minus 1 equals 12. Okay, now I'm going to square both sides. So 3x minus 1 equals 144. I'm going to add 1. And 3x equals 145. So what is that? X equals 35? Again, I'm going to check it. I'm probably actually going to plug it in right here before the square because I think that's the easiest place to check it. So 3 times x, so 3 times 35 is 145 minus 1 is 144. So the square root of 144 does indeed equal 12. My answer works. My answer checks out. No extraneous solutions. All right, I want you to go and try the next two. Now I want you to notice number 5 is a cube, right? Number 5 is a cube. So press pause, come back, and let's see if you did it right. All right, so you just tried the cubed root. Now hopefully instead of squaring both sides, you recognize that you'd need to cube both sides, giving you x plus 1 equals 64 and x equals 63. Again, still checking to make sure we don't have any extraneous solutions, but 63 did work. And then number 6 had radicals on both sides. I had 2 radicals. So that's actually the same thing. You square both sides, getting x equals 5. When you plug it back in, I did get the square root of 14 equaled the square root of 14. So my answer works. Okay? All right. But then we also talked about rational exponents. So how do we undo it? No radical, but you do have a rational exponent. Remember that a square root is the same thing as raising it to the half power. So wouldn't we square or raise to the second power to undo the square root if we have to get back to the variable? All right, so one way to solve these is to think about it that way. Basically what you're doing is you're raising both sides to the reciprocal of the power that you're trying to undo. So for example here, x to the 6/5, you'd be multiplying by, or you'd be raising it to the 6/5 power. So that would give me x equals the 6/5, 5 6 times 6/5. When you multiply reciprocals, you get 1. 32 to the 6/5 we know means the 5th root of 32 to the 6th. The 5th root of 32 is 2. 2 to the 6 is 64. Does that make sense? Okay, and if we test our answer, 64 to the 5/6 gives me the 6th root of 64, which is 2, to the 5 power, which is 32. And so it checks out. All right, we're going to practice more of this tomorrow in class. I hope that was a helpful video in learning how to solve equations with radicals and roots. Have a great day.